Welcome back, as we next deal with studs. For purposes of demonstration, we shall remove the old studs from this valve and replace them with new ones. As the studs are looking a little corroded, we'll apply some penetrating oil to the threads as an aid to removal. We shall be using a stud extractor featuring a knurled wheel, which is fitted, as demonstrated, to a socket driver and placed upon the stud. The knurled wheel is pressed against the stud, and then by turning the socket drive, the jamming action will force the wheel to bite into the shank. The stud is removed simply, as demonstrated, by turning it out. Note, however, that threads will be damaged by the wheel. If you do not have a stud extractor, then the following method may assist you, using 2 nuts. Fit 2 nuts onto the stud as demonstrated, ensuring that they are turned fully down onto the threads. Use 2 suitable size spanners and firmly lock the 2 nuts together. Then, with a spanner on the bottom nut, turn out the stud as demonstrated. It must be noted that this method may not always work on heavily corroded studs. Once we have removed the studs, we must next check the size, thread and length for replacement purposes. Assessing of size is the same as for any other fastener, by measuring over the threads. A true engineering stud features a short threaded section and a long threaded section. On imperial studs, the short section is usually coarse threaded and the long section is fine threaded. The length of all studs is given as the total length, tip to tip. Most engineering studs are made of high tensile steel, usually of grade 8.8. Mild steel is also used for commercial quality studs. Studs are fitted or set simply by threading the short threaded section fully into the threaded holes. They are then secured with the 2-nut method, whereby we tighten the stud by turning the top nut as demonstrated. When secure, the nuts are released and removed. After the break, we shall look at some good working practices.